Howdy brothers and sisters, we're at our Creation Ministries here, headquarters, to start our excursion today. People are turning up now, the kids are here, and we'll keep filming other bits. This is the handout. All the people. Hey kids, they're looking at all the books.
Dinosaurs, they're on display in the museum. So there we go. And they're very well preserved, indicating that, you know, there's paleontologists who dig it out say, wow, there must have been some catastrophe here. And there was. It's called catastrophe there. And so there's evidence for catastrophe.
Studying the rocks at the gate. This is CMI headquarters, and we're just looking at the rock piers here.
So the quartz is because the rock is cracked, and so there's water gone into the crack, and it's deposited quartz. And then after that happened, the rocks have, you know, there might have been another.
Look interested, kids.
Yep, no.
Everyone hopping on the bus.
Yep, that's pretty good.
The rowdy Hamiltons are up the back. Yeah, we're on our way.
What are you doing?
To the first stop. Everyone's on the bus. That's Dr. Taz Walker up the front. So we just have a look at the piers at the CMI head office, and we're off to our first.
Going here? That's right. Okay, we want it through. Wait a minute, we will just.
This is our first stop.
Something there as well, and you can see there's a great big heap of it. There's a lot of gravel, you'd call it, wouldn't you? You'd call it gravel, and you can see that. How big is it? There's it's pretty coarse. See some of this stuff. That's part of it. It looks like it's coarse. I don't think that's concrete. You got to be careful.
Yeah, you guys wondering about that.
Yeah, but you can see this dark stuff again. It looks like the stuff we saw at the front gate, and so you can see that it's all the way up there. You can see some of those little pieces up higher.
That's picked up. Is that quartz?
So what's cemented together?
Yeah.
What cements it together? Well, that's a good point. It's basically gravel, so it's basically a gravel as you find in a riverbed, and when you walk in the gravel, it's soft, isn't it? So usually, if there's water, because there's water with it that was deposited, it's deposited what they call a cement, and so it's not very well cemented because it's so friable. But there's a cement. It could be quartz that's deposited and holding the grains together. It could be limestone, or it could be ironstone. It's unlikely to be ironstone because it would be red colour. So it's probably got a weak cement of quartz that's holding it together and just giving it a bit of. In a creek, you have gravel in a creek, and the water is clean. It's, you know, you can drink it. It's not full of minerals, and so the water doesn't. There's nothing there to cement. Generally, to cement the gravel alongside in a creek bed or a riverbed very easily. But it does happen. But usually it doesn't. Yeah. They study sedimentary rocks, and sedimentary rocks are very fascinating because there's so many things about them. And so, for example, you've got the grain shape. See, so that's the things they look at it. What shape are the grains, and they'll describe the rock. And then they've got, well, on page 3. Sedimentary rocks, it's got the classification. So a sandstone, if you see there, is anywhere between the little grains are less than 2 millimeters, which is fairly large. You know, it's a fairly coarse sand. It's not a major effort. And then they will sort of describe it the way I describe it. They will say that it was deposited by water, and they'll say that it was quick.
Yeah.
They will say that. They might say that it is deposited over 1 million years.
That's what I want to understand.
They would.
Their idea of quick.
Yeah.
That's their idea of quick. This is sandstone. How's everybody? Good, I'm doing all right. There's a lot of slabs, and they're falling down into here. So, I don't know when they started falling down, but if you look at this sandstone here, and you can look across, you can see sandstone on the other side of the creek. You see that? So, the sand once went right across, and then this bit has all been eroded out. And so all the stuff that's been eroded out has been taken away. Right, so it's all gone out somewhere. So probably the major erosion was probably the very tail end of the flood to move it all out. But there's still stuff that's falling in. So these big rocks are still falling in. But there's not a lot of them. Like there's a few of them, but it's not full of these rocks, is it? It's just a few of them scattered down here. The oceans, they took a lot of stuff back into the oceans, and that formed the continental margins, the continental shelf in the oceans as the water came off the continent. So you've got to think in big terms, okay? So any questions about this? I mean, you can see it, feel it. It's got nice cross bedding. You can see geologists always have a hammer because they don't like all this stuff on the outside, and they hit it to break it off, see what it looks like fresh. But we can't do that here.
On the dam and the like, you've got mudstones and sandstones, right? So different energies, as I said, different materials, but once that weathers, it weathers into different types of clothes. And that's probably where you're looking at, say, weathering.
Everybody okay? You got any questions? Is it puzzling or is it okay? Nice. Yeah. So here we go back to it. So he doesn't imagine that happened. So he tries to interpret these rocks according to the things we see happening today. So he says, oh, we do see rivers flowing today, so this must have been deposited in a big river. Right? So he'll say that. And then he imagines it must have taken a long time. So when he finds a dinosaur fossil, he thinks, oh, the dinosaurs must have lived a long time ago. Right? So that's his glasses. So, but we sort of look at it from a different perspective. We say, well, we believe that the Bible is recording the true history of the world, and the world is only 6,000 years old, but it's not hard to calculate that from the Bible. And
This is our second stop. It's near Griffith University in Brisbane.
on the list, Zelda's on the list, that's right. So what do you notice about this? It's tilted. It's folding. Where do you see the folding? Could be the cracking, or you could see the sort of folding like that, can't you? No? Maybe cracking.
Oh no, really?
A spider. So are there little pieces of it somewhere you can look at?
Yeah, there's just pieces here.
Might be some down.
Still very coarse inside.
Some on the ground. Some on the ground.
Down here.
So so it looks like it's on an angle, doesn't it? Does it look like it's on an angle? So it's hard to know whether that is what you call the bedding or whether it's the cracking that's on the angle. You know, so, and so that you can pass that around. That's just a little piece that came out. Is it, what's that like? Is it coarse or soft? Is it fine? It's like a mudstone, isn't it? A metamorphic rock. It's not a sedimentary rock. It's sort of halfway between. They're now folded and steeply inclined. So there's argillite, fine-grained sedimentary rock derived from mudstone or shale. So it's, they call it argillite. They don't call it mudstone because it's sort of not quite like that. There's a grey wacky, hard grey, coarse-grained sandstone with angular particles. So I can't see the grey wacky here. And then there's chert. So unfortunately we're not going to see the chert or the green stone. But anyway, so have a look. When they first saw this on the early maps of the Brisbane area, they put this, they labelled it as Precambrian. So which is sort of very, you know, very old. Whatever I got there. So on this, it's Precambrian is even further down on this chart. That sort of thing. It's like that. And so this stuff is in this rock, and there is actually some up there, but it's all crumbled up and it's very hard to see. But anyway, see that? See, with little remains of some marine creature. They found these, and so based on that, they then changed the date of the rock from Precambrian to, I think it's Carboniferous, is it? What is it? Column is like a filing cabinet, and they look at a rock and they stick it in a file somewhere. And then they think, oh, it doesn't really belong there, we should put it down here or should put it up there. So they try to work it out so it all makes sense, you know, in geology. All right, and so, you know, Precambrian doesn't really fit there, and so they keep moving it until it sort of makes sense, you know. It's sort of consistent, you know. And so when I first saw it, I thought this might have been creation rocks, because there's nothing, you know, when God created the world, initially you wouldn't expect in the creation week to have lots of dead things in. It hasn't got any fossils in it. I thought it was possibly creation rocks which are folded in the flood. But because they found those other things, I think it's really actually flood rocks. So it's early flood, that's why I put it there. Yeah. The iron just sort of comes out of the rock and sort of stains it in different places. Yeah. Okay, tipped up. And it's part of, when it's tipped up, it's part of, like, it would go over and, you know, it forms a fold, you know, so you find it somewhere else. But it's pushed around. So in some places, the folds are easy to follow. Like if you go down to Victoria, there's areas which are folded and you can see them, they're really easy to follow. So what do you see here? What do you notice?
Very fine layers.
These are very fine layers here. That's a little bit like what we've been walking past, isn't it? This down here? Down here? But the tops, what's that? It's different. So it's different sort of rock on the top than at the bottom. And they call this, there's a diagram of it, it's called a, what's it called? It's an unconformity, thank you.
Unconformity.
It's in there, there's a page, it's about
Lily,
page 3, 5, 7 or something like that.
Are you unconformity?
Page 6. Page 6.
Unconformity?
Page 6. So it's an unconformity. And so this is, this rock here is part of the green rock which we've been looking at, which is part of the Woogaroo subgroup. Right? And this is the Nerranlee Fernvale. The Nerranlee Fernvale beds are, what are they? They're Carboniferous. So it shouldn't be basin, that's part of the Woogaroo subgroup, and that's supposed to be something like Jurassic, which is supposed to be 145 million. So how many years is that between that? 320 to 100, hey? 100 million years between that and that.
Where did the rest of it go?
Where did the rest of it go? That's a good question. So that's one of the issues that they have, is that the contact between these two looks so fresh. It looks so flat. No sign of smoothing, no sign of gullies and that sort of thing. Yeah, in 100 million years. So anyway, so that's the
Must have been
contact.
boring.
And you can, if you like, way, and the dinosaurs, which probably amphibious animals, were not worried about being in the water. We also think
The human beings?
no, the dinosaurs,
Oh, okay.
and they are able to swim, you know, well, and so they.
This is the third stop. I think we're having lunch soon. Kids are interested in lunch.
A weathering thing that's sort of just the way it weathers. Yeah. So this is like, we're on the other side. So we were looking on that side, and you can see the fine material, which is fine, but this is the coarse. It's like a sandstone, but it's not really a sandstone. It's a sandy, muddy sandstone, which all sorts of size grains. And I think it's a bit coarser than mud, isn't it? But it's sort of gritty stuff. It's almost I think it's WLY. I never can remember how to spell the name. No, it's not a volcanic reaction. No, it's a very fine. It's a fine sediment which has been tipped up, and so you know part of the movement is the tipping up. It sort of means it's sort of not quite straight, you know. Plus, it's the way it's eroded. It's eroded in unevenly, and that sort of shows that there's waving. It's the erosion.
The upheaval isn't caused from volcanic reaction?
The upheaval is probably caused by movements in the crust, and those movements cause volcanoes. But they, you know, the movement, you know, like the energy that's produced as it moves, melts rock, and then the rock comes, the molten rock comes. Eh? Yes. Just like hydroelectricity, energy as the water drops down, so movements of the rocks, big movements produce heat. Yeah.
How long does it take the sediment to become hard rock?
How long does it take for sediment to become hard? It doesn't take long, it just depends on the cement that's there, right? It's the cement that makes it hard. And like if you think of concrete, if you've got, there's a certain cement with concrete, there's a certain, like thing, there's a limestone that's a chemical reaction. It's a chemical reaction and it takes hours, you know.
This would have probably remained fairly plasticky for some time.
Yeah, but this is also still quite soft. You could probably scrape this off.
So what is this?
This is just a fine sediment, you know, that's just exposed. It's fairly friable, easily eroded. So this cutting would have been cut by a bulldozer, and then it's eroded away. Yeah, and you can see the big blocks of it slipping down. And I'll put this here. This is quite slippery actually because it's all pine needles. So hopefully I'll be right. We'll go to lunch in a minute.
You wouldn't want to have lunch before you went up that hill.
So here we've got the this is the top layers of the unconformity, right? So these are the bottom layers. If you have a look at this, you can see that there's a lot of large pieces of rock here. Big pieces. You can actually identify it. It looks like what we've already seen, you know, outside our office.
Sorry.
And can you see that? That's how big it is.
Yeah, big pieces.
Big pieces. They're all the way through there. And there's big pieces there. So it's sitting on top of this. This is the sediments of the Narrenleaf Fern Vale. I probably shouldn't pull it off, but anyway, I don't know if I can. But this feels very much more like a sand about Jurassic dinosaur. And so these rocks are connected. They go way up, and if you go out to Winton and out, you know, past Roma, It's the same sort of stack of rocks. They're kilometres thick. And here we are looking at them here. And so there you go. Rising. And as the floodwaters were rising, there was stuff deposited and things folded and things moved and volcanic eruptions and other sediments. So that happened as the floodwaters were rising. And then as the floodwaters went down, it eroded stuff from the top and formed the landscape that we see today. So that's in a nutshell how it works. It's very simple. It's a very big picture. It's a big scale thing that happened. And it all sort of fits together and store stuff that happened. But, you know, we're not 100% sure today. But we know that the Earth is made of these tectonic plates, and so it's quite possible that the waters came up through the cracks in these plates and that produced material. Even today there's material comes up from these plates. There's mid-ocean ridges, there's water comes up. And also people have found out or discovered that there's water inside the Earth, something like 400 to 600 kilometres under the Earth in the mantle. And there's enough water there to fill the oceans still to some 12 times. And it's called Water in the Mantle. And if you go to creation.com, there's articles about this. And every now and then there's a report that gets in the newspaper about some new discovery on this. But there's a lot of water that's still in the mantle. And so that could easily be where it came from in the flood, was released from the mantle. So we'll go and have lunch, but we'll talk about dating after lunch.
And that's Hornfels too, is it?
It looks like Hornfels. It does look like it, doesn't it? Yeah. So, I mean, just on your site, it looks like it. And that doesn't look like... That's a piece of quartz. Yeah. So, again, it's ripped up this stuff and deposited it. Quartz.
What's that rock called, Lily? What's that rock between your ears called, Paddy? Paddy. Paddy.
Build the alpha tree. Damn.
Oh, yeah.
Build the alpha tree.
Okay, this is our stop number 4. Kangaroo Point in Brisbane. Brisbane City. Kangaroo Point Cliffs.
Because that's how people want to learn these days. And, yeah, we're going. Can you take from my jump?
What was that, Callum?
Yeah, the front, no? Because
apparently we're going to look at some of these rocks in the rotunda.
So it's a volcanic eruption, and so as the volcano erupts, it picks up rock from the satellite. Yeah. So does that look familiar? Yeah. She's just become friends with the rock.
So what's pumice done?
Pumice is like this, but it's formed by bubbles. So the lava comes out and it's full of air and it forms bubbles and it becomes very light. Yeah. So and it makes holes in it while it's still molten and well, there's coloured lava, and you can get dark coloured lava, and you can get in between. And so they give it different names. The light coloured lava, if it's fine grained, it's called rhyolite. And the dark coloured lava, if it's fine grained, it's called basalt. Right? So that's and so it's just a different composition of the lava. So the light coloured lava is got a lot of silica and aluminium in it. Silicate, and so it's forms light colour. The black coloured lava's got lots of magnesium and iron in it. So the dark coloured lava forms a nice black or red soil. The light coloured lava doesn't form much in the soil. I've been caught, don't worry.
It looks like composites.
Yeah, and you see there's the various cracks, and so the cracks tend to get iron in the crack. The water goes through the crack. The water's got iron in it, and so it forms iron, gets into the rock. And so if you break the rock there, it would form like that. See? Is that bubble gum? Looks like it. So there's another one. You recognise that? So it's probably come through. You know, we've had a look. No, we haven't had a look yet, but it's probably come through the area of the Earth which had that type of rock in it, and it sort of picked it up and brought it up with the volcano. And so you can see how high we are. So this layer of rock is pretty high. I don't know, how high are we? 30 metres high? Something like that. So it goes all the way up north of Surfside, all the way south to this great big area. And then just in town, we're going to drive down up to Ann Street.
I don't know.
I'm not going to try that.
Looks like ash or something.
Or dark. I'm just not sure.
I have no idea.
You know, go out on a rocky area, you often find these sorts of stains in the cracks, and often if it's along here, it sits a bit higher because the iron is harder and it's a bit higher. Yeah? During the flood. Yeah, so the Nerranly Fernvale beds, you know, they were early in the flood, and then these erupted on top of the Nerranly Fernvale beds. So and then the ongoing flood has sort of eroded that off, and then the Woogaroo subgroup went on top of that, you know, so it's an ongoing process.
Do we know what the bed of the river is?
Probably the bed of the river. I know that the Clem tunnel goes through this stuff.
Yeah, Amanda was involved in the early stages of the design of that, and got some intel on it.
You can't remember.
30 metres.
Rocket goes through. I think
It goes through numbers of different ones, but it does go through some of this as well. And that's under the river.
But the river's quite deep up there, isn't it? So
it's very, right at the point of the cliffs there, as the river turns the corner, it's very deeply incised into the bed. It's normally covered up by sediment, but whenever we have a flood here, it pushes that out. It's very deep. So that's why the tunnel goes through.
So my sort of take on it, like if you look at the geological map, you can see the order, you can see the Nerranly Fernvale beds, so they were laid down, and then they were folded, and then on top of that you've got this, which is the volcanic eruptions, and then and also on top, you know, it's really hard to tell if it's later or the same time, is the inaugural granite. So the granite is underground, and this sits on top of the ground. So this is erupted on top of the ground. So I wouldn't be surprised if the granite and this are sort of connected. You know, the granite's the underground chamber, and this is erupted on the surface. And I wouldn't be surprised if the folding of the Nerranly Fernvale beds is actually what generated the magma, which then erupted. So
well, there's some sort of going north where the Nerranly Fernvale meets the Roxburgh Greenstone meets the edge. Substantial fault zones there. It's in the foundation of North Pine Dam.
Oh yeah.
So it's well investigated.
Yeah.
And would indicate that there's been, you know, some quite substantial seismic activity associated.
Gives us a good picture of the size of it. That's really, and this is only part of it. It goes, of course, down another layer as well, and so you can see what it looks like. You can see how big a chunk it is. It's not as if it's in little layers, but it's one big chunk, as if the whole lot was deposited at once. And yeah. So that was a big explosion. But even this one is not a big deposit compared to other deposits during the flood. But it still is a big one. And I thought I might just talk about radioactive dating just briefly, if that's all right. So I don't know, what time did I say we're going to finish? 12. What time did I say?
He's on the bus with you.
Yeah, I just want to make sure I'm not don't hold us up too late.
Sorry.
2:20 wasn't 2:20, so we'll be back. So the thing, how do geologists work out the ages of rock? Basically, we did a little summary about what came first, you know. So that's how geologists work things out, what came first. So they know which one's the oldest, they know what's next and what's next. And of course the problem is you can't always see the contacts because it's covered in trees and all sorts of things like that. So you can't always see it. And so, but basically they call that the field relationship. So if this rock is sitting on that rock, it's clear that this rock is younger and that rock is older, right? And so they know that from observation, just observing the rocks. But how old is it? Doesn't have labels on it. And so originally, before radioactive dating, they used to try to work it out by working out how long it would take to deposit, you know, 1,000 meters of sediment at so many inches in 1,000 years. You know, they used to work it out that sort of way, and they try to get an estimate of how long it would take. And of course, that is very unreliable because the deposition could change, and they were never happy with that anyway. But it gave long periods of time. And so when radioactive dating came in, geologists tried to use that as a way of working out the ages of rocks. Now the thing is, you know, I do a little experiment, or put up a little thing about a hourglass, like what do you call it? A measuring cylinder which has got water dripping in. You might have seen me do that, I don't know if you have. And you can measure how much is in the cylinder. Very accurately, 300 millilitres is in the cylinder. You can measure how fast it's going in. It's going in at 30 millilitres an hour. So you can calculate how long it's been going in. And everybody says, yeah, 10 hours, right? And I say, well, I set the experiment up, and that's pretty good. That's exactly how they do it. That's 300 divided by 30 is 10 hours. But it's the wrong answer. They say it's only been going in for 3 hours. Can anybody suggest what might be the trouble?
Higher flow rate.
Yeah, that's right. And people will then start coming up with ideas. Could have been a higher flow rate in the past. Could have been some dropped in. Could have been this. Could have been that. And I say, yeah, it could have been. But how would you know? You wouldn't know. Unless you actually saw it, you wouldn't have a clue, right? And you wouldn't have known it was the wrong answer, except I said it was the wrong answer. And I said, and so I just make the point that it's impossible to measure the age of something by just making measurements in the present.
I also think the point that one of your journals or something said someone went off and actually tried to measure known age volcanic rocks with radioactive dating, and they said they should all come in too young, because the idea is that there's the parent and it degrades the child, and you work out the ratio and you've got your age. And they went and measured in Hawaii and Mount St Helens in New Zealand and Mount Vesuvius or whatever, and they all came back with ancient dates because the cylinder was part full on day one. There wasn't zero. So it was really sensitive to the fact that the gas, the argon gas or whatever it was, hadn't been all blown off. It was actually a starting point.
And so by the time solidified, there's no argon. That's a good story. They're talking about things in the past, so it's a story. It's just making up. So the idea is there's no argon in this volcanic lava when the lava solidifies into rock. So that means any argon that we measure, you know, daughter argon that we measure, must have been generated by radioactive decay. So we do a little calculation on it, and we calculate an age. And so you come up with an age based on the argon that we measure, and that the other stuff we do the calculation, and you come up with an age of 50 million years, say. And of course, when they do that calculation, they've got no idea whether it's right or wrong, because they don't know if their assumptions are right or wrong. So how are they going to figure out if the answer's right? So what do they do? Attractive building stones and things. Okay, I just thought it was really worthwhile coming here to have a look at this. This is an old quarry. There's still a number of quarries in the granite, and you can see a geological map of this on page 8. And so you can see it's just a part of a great big oval exposure outcrop of granite. So the granite sort of goes, it goes up Mount Cootha. I think it goes up there. And so this is granite, and it's been quarried. And you can see on the geological map, sort of just to one side of the granite is the Hornfelds, right? So you've got the granite, which is a light colour. Would you agree it's a light colour? And it's also got the iron staining on it, and it's also got this black, you know, that's some sort of algae or something like that that's come on the rock by being exposed. They go black and get unfortunately ugly. But over that side you can see that there is some grey rocks there. Can you see the grey rocks?
Yeah.
So that's the edge of the granite. So that's the Hornsfeld. If you just got to imagine this area, it's a great big pool of molten rock. And under the ground the rock is called magma, and so it's come up through the ground and it's pooled under the ground, and it's probable, you know, we don't really know, but it could have had a kilometre or a couple of kilometres of rock above this, right, that was above here. And so this pooled under the ground probably as the Nerendly Fernvale beds were folded. And so there's the Nerendly Fernvale beds. If you look at your geological map, you'll see that this is in what's called the Bunya phyllite, which is similar. And they just give it different names because it's just slightly different in its appearance. Kangaroo Point, that's probably hands down. May not be, but it may be.
Hey, what about
So they don't want the sediments which it's intruded into.
I think this is stop number 5, but it's a bit hard to hear Dr. Taz through the phone, but anyway,
The other good thing is that they have
I'll have
put
to
a
edit
nice
this
couple
video.
of pieces of granite here.
That's iron hydroxide.
I mean, the roots are like
Yeah.
his greatest.
you are a
yes, so the audio on this is probably not going to come out that good, but anyway, it's been a good day. I think this is our last stop. Stop number 5. If you count lunch, that's 6.
Kaz, why is the pink granite pinkier there?
I don't know.
I associate that with potassium.
Ah, could be potassium, pink potassium. I don't know the answer to that.
is this one tough here?
No, I don't think that's tough. That's a grey granite, placed pretty well at the same time. Pretty close to being at the same time. Otherwise, you'd find various breaks in the rocks, you know. But it's been placed at the same time. It's a complete amount of lava to go in would fill the whole lot up at once, and it makes it a nice solid mass. Well, it has to be quick in order to be still liquid, doesn't it?
Talking about the
I think you're looking at days. Yeah.
It's called mud springs.
Yeah.
I wrote down what it's called.
It used to be thought that granites would take a long time to form and a long time to cool and a long time to crystallise. Well, that's changed. Like geologists have sort of, there's been some papers done, and we've got articles on our website that talk about it, is that they can form quickly. There's evidence of them in being placed quickly and of crystallising quickly. You can get like little crystals form of the granites within hours. You can these days, and they used to think it took millions of years. You know,
So diamonds, industrial diamonds can be made in
days and hours.
and it's hard to discern between.
Yeah.
Well, that's it. We're heading back to CMI headquarters now. It was a good day. I think the kids had enough. You had enough, kids?
What are you doing? Just stop.